Okay, welcome to the fourth standard we are reviewing. Remember, they're always listed. Oops, my pen's not working. At the top. Let's close my pen out and see. There we go. So now this starting off with is literal equations. So the big thing with literal equations is there are no numbers. We are just pretty much dealing with equations. So I notice right away it wants me to solve for t. So that means it has to equal t. So this last one right away is wrong because I had a t in the denominator. So notice in that denominator, see Mr. T, he's wrong spot, so he's gone. Now I notice all the others are equal to t, so we are doing good. Nothing else I can just eliminate. So now, to solve for t, the first thing I want to do is get rid of p. So I'm going to put that p on the other side. So I have a minus p equals prt. So don't forget when I have letters next to each other, that's multiplication. Whenever I go to the other side of the equal sign, I always do the opposite. So our final thing I'm going to do is divide by p and r, because then p divided by p is 1, r divided by r is 1, 1 times t is just t. So then I get a minus p over pr. Don't forget, you could also have had it written negative p plus a over pr equals t, would mean the same thing, not different. So when you're looking for the correct answer, you always know that you can flip-flop things like that so that you can find the right answer. Answer is B. Next, a line represented by this equation. What is another way for the same line? And that's kind of what I was talking about with number 1, where it says there's other ways to solve or to represent. So notice with this one, all of them I am solving for y. So these are still considered literal equations. I'm going to take this equation in standard form and put it in slope-intercept form. So I start off by subtracting 3x from both sides, and I always like to keep my x in front of my whole number. So I have 2y equals negative 3x plus 4. Keeps it in the slope-intercept form. Then I notice I have y, and I want to get it by itself, so I divide all terms by 2. So I wind up with y equals negative 3 halves x plus 4 divided by 2 is 2. So I look for the one that has negative 3 halves, cross off the ones that don't, and then I find that a is the one that has plus 2. Number 3. If k equals am plus 3mx, find, or the values mk in terms of a, k, and x can be expressed as. So what they're asking is in term, for this, means that, m equals. So I notice right away here, notice an m there and an m there. So that's a common factor, and I'm going to pull them out. So I have k equals m times a plus 3x. So don't forget, all I did was pull out a common factor. I did not do anything else. If I distributed it, you would notice I would have gone back to the original equation. So I know that when I have a letter next to another letter, it's multiplication. So this whole set of parentheses is just like another term times m. I can divide both sides by what's inside those parentheses, and it's going to cancel because it's just like dividing something by itself. So I have a plus 3x. So that tells me m is going to equal k over a plus 3x. So that gives me a. Okay, last two. Number 4. A formula is expressed there. So this k is what I'm solving for in terms of dA and t, meaning I don't have numbers for it. I just want to leave the letters alone. So notice this time, look at where the k is. It's inside the parentheses. So I have to start off with distributing 2a, and I always put my my coefficient before the variable. And try to keep things in alphabetical order. It helps you with organization. Next thing, just like 2 problems ago, I am going to subtract the 2a from both sides to start. So I have d minus 2a equals AKT, because now I can divide both sides by AT to get k alone. See, a divided by a is 1, t divided by t is 1, and that leaves me with just a k. So I wind up with k equals d minus 2a over at. And then I look for the one that looks like that, and there's my c. Last one. Tim was asked to solve the equation for x. There's his solution. Where did he make his first mistake? So I start off, I find it easiest to go ahead and just do the work out. So the first thing, if I'm solving for x, is I probably personally would have started off by getting the mx, negative mx to the other side, so I have all my x's on one side, which they did the same thing. Then I would have factored out an x, which they did, and then you divide both sides by k plus m. These are the kind of equations and stuff that they kind of get you on, because you're like, whoa, what happened here? There was no mistake. That is an option. So don't forget, that's always an option, because step 2, just like the equation 2 ago, I can divide both sides by k plus m to get my x alone.